Hello guys, this is Deepak Singh, your physics faculty. Now we start the class 10 physics. The chapter is what? That is electricity. Okay. Now we are discussing the lecture number 3, right? You studied current, potential difference, the work done, the charge in the lecture 1 and lecture 2. Now we are going on the lecture 3. In this lecture, we are covering the topics like the Ohm's law, right? Like the resistance, like the factor of acting to the resistance. Next one is resistivity and some numericals related to them. Okay, dear? Right? Now we are going on the topic that's the Ohm's law. That is the superstar topic in this chapter. Right? So understand what I am saying to you, that in the Ohm's law relate the two physical quantities. Ohm's law relate the two physical quantities, gives the relation between the two physical quantities. Which quantities? Like the current and potential difference. Okay, the scientist who give this, that is a George Simon Ohm. Okay, my dear. So this gives the relation between the two electric quantities, right? What? Electric current and potential difference. Okay, my dear. Let's suppose there is a cell. There is a single cell. There is a battery, and the current is flowing from high to low, and we know that. Right? We know that current is always flowing from high to low, right? Electron is flowing from low to high and current is flowing from high to low. When the current is flowing, then the bulb will be glow, right? And the bulb glow. Now second one, when we apply the two batteries, then what happen? Also current is flowing in it and the glow of the bulb is more, right? Now we apply the three batteries. When we apply the three batteries, then we find that the glow is more brighter. Okay, my dear. So we can say that what? So we can say when current is flowing in a conductor, what? When current is flowing in a conductor, that is proportional to the potential difference. What we say? Current is flowing in a conductor through a metallic conductor is directly proportional to the potential difference, right? Across the ends, provided its temperature remains the same. Okay, the important conditions is length, cross-section area, temperature and material should be constant at here, right? If they are constant, then at this condition, the current is flowing in it is proportional to the potential difference. Okay, so if length, area of cross section, temperature and material remains constant, then the current is flowing is proportional to the potential difference across the ends of the conductor. Hence we can say that V is proportional to I is proportional to V, then we can say that V is proportional to I. If we remove the proportional sign, then we have a constant, right? And that constant is what? That constant is R, and that R is called the resistance, right, my dear? Right? So R is what? R is the resistance. Okay, so now V equals to IR, right? It is the standard formula and this is called the Ohm's law. What is this? This is the Ohm's law, right? Complete Ohm's law. So in the Ohm's law, we find that Ohm's law gives the relation between the two physical quantities, that is current and potential difference. According to the Ohm's law, the current is flowing in a conductor is proportional to the potential difference across the ends of the conductor, where when length, area of cross section, temperature and material remains constant. Okay, in that condition we find that V is proportional to I, that V upon I equals constant, that is R, and that R is the resistance, right? What is resistance? Let me start. So my dear, the topic is, the question arises, so what is resistance? What is resistance? Okay, so let's suppose there is a conductor. In this conductor there are the atoms and the electrons, right? And we know that when there is no supply connected to the conductor, the electrons have the random motion. Electrons have the random motion and their average velocity is 0, right? They have the random motion. There is no flow of current because they have the random motion. They do not have the specific direction motion. Not. They have the random motion. So the current is 0 at here, right? Here there's a conductor. When it is connected to the supply, the potential difference V, right? There's a higher, there's a lower terminals. Current is flowing from high to low. An electron is flowing from low to high. Okay, so these electrons have the specific directions, right? In this condition, what happen? So if when the atoms are more, the resistance is more. If the if their atoms are more, so electrons are more. If the electrons are more, they have the lot of collisions. And if they have the lot of collisions, they have the high resistance. And if the resistance is high, then current is low. Right? Because if resistance high, then current will be low. Okay? And if resistance low, then the current is high. So basically resistance is what? Resistance is the opposition. Resistance is the oppose in the flow of current. So my dear, what is resistance? Resistance is the oppose. Resistance is the opposition in flow of current. Okay? Right? Okay, let's see. When the atoms are more, resistance is more. If and the current is less, as you know that atoms are more, electrons are more, and current is less. If atoms are less, resistance is less. Atoms are less, very small number of the atoms, small number of electrons, so they have they have almost negligible collisions. So the current is more. Okay, done it. Done. The current is more. Okay, so we can say that the property of the conductor due to which it opposes the flow of current is called the resistance. Okay, this is the definition of the resistance, actual definition. The property of the conductor due to which it opposes the flow of current is called the resistance. Is it clear? The definition of the resistance is clear, right? If the atoms are more, resistance are more. Resistance are more, current is less. If the atoms are small, resistance is small, current is high. Okay, dear? Complete? The definition of the resistance complete? Okay, so now we are going on the formula. So we can say that R equals to V upon I. As we know that Ohm's law, that according to the Ohm's law, that V equals to IR. Right? So here the R is V upon I. Right? So V upon I, V is the potential difference, I is the current. So we can say that the SI unit of the resistance is volt per ampere. Volt per ampere. And the volt per ampere is known as, according to their scientist, Ohm, George Simon Ohm. This unit is decided. And the unit of the resistance is what? That is what? That is Ohm. Okay? Done? So we can say that Ohm is what? Ohm is the SI unit of resistance. Or it is volt per ampere. Right? Any doubt? No. Okay? So, when we say that resistance is 1 ohm. When we say that resistance is 1 ohm. Okay? So, if the potential difference across the two ends of the conductor is 1 volt. If the potential difference is 1 volt, then we can say that the current flowing in conductor is the 1 ampere. And the current through it is 1 ampere. Then the resistance of the conductor is 1 ohm. Is it clear? It means resistance depends on length. Second one is cross section area. Let's see in the next slide. So here we find the definition of the 1 ohm. When the conductor has the resistance 1 ohm, if 1 volt potential difference is applied across the conductor and the 1 ampere current is flowing in it, that means the resistance of the conductor is 1 ohm. Okay, my dear? Now we are going on what? The factor affecting the resistance. The factors affecting the resistance. On what factors the resistance of the conductor depends? Right? So first is what? The first is the length. If the length of the conductor is increased, then the collisions are more. If the length of the conductor increase, then the collisions are more. If the collisions are more, it means what? It means resistance more. So resistance is proportional to length. Okay. Second one is cross section area. Area of cross section. Right? If the cross section area is more, then electrons are moving easily. So they have the less collisions, less resistance. So it is inversely proportional. What? According to length, R is proportional to L. Length increase, resistance increase. R is proportional to 1 upon A. If the area is increased, then the resistance is decreased. Because if the area is increased, the electrons are moving freely without less collisions. Okay. So if the area increase, resistance decrease. Okay. Third one is what? Third one is temperature and material, right? Resistance depends on the material. If we have the copper and aluminium, both have the different resistance because both have the different materials, right? So material. Last one is temperature. If we have the copper wire and if we increase the temperature of it, then we find that then the resistance is changed, varying regularly if we increase the temperature. So resistance of the conductor is depends on some 4 factors, right? Understand? So now we can say that R is proportional to L. R is proportional to L. Second one is R is proportional to 1 upon A, right? If the size of the door is small, then the people entering in this are large. So what happened here? If the cross section area is small, then the resistance is what? Resistance is what? Resistance is high. If the cross section area is small, then the resistance is high. And if the cross section is large, then the resistance is low. Okay? Done it by this example. You understand? Okay. So now, so we can say that if the door is wider, then more people can enter. Wider. Cross section area is more. Resistance is less. Okay. Now, if we can say that if the wire is thicker, so we can say that if the wire is thicker, then more electrons can flow. Right? Okay. Or resistance is less. Now, hence R is proportional to 1 upon A. Right? Done it. So first of all, R is proportional to L. Second one is R is proportional to 1 upon A. Okay. Now next, when we combine them, then we find that R is proportional to L upon A. Right? If we remove the proportional sign, then we find that what? There is a constant. That constant is rho. Right? So we find R equals to rho L upon A. Here the rho is what? Rho is the resistivity. Rho is what? Rho is the resistivity, right? So this is the formula of the resistance, that R equals to rho L upon A. Okay, my dear. So here the unit of the resistivity, we can say that R equals to rho L upon A. It means the rho equals to R A by L, right? So the unit of R is ohm, right? That A is meter square, that L is meter. So after cutting it, then we find that ohm into meter. So the SI unit, or we can say that a unit of resistivity is what? That is ohm into meter. Right? Understand? Ohm into meter. Okay. Now, next, practical understanding of the resistivity. What is practical understanding? Let we have electric circuit. Right? Here, a ammeter is connected. Ammeter is used to measure the electric current. And voltmeter is used to measure the potential difference. Okay. What? Ammeter is used to calculate the electric current, measure the electric current, and voltmeter is used to measure the potential difference. Okay, my dear. Here the ammeter is connected. Okay. Here the circuit is open because there is a break between the A and B. If we have the copper wire, then the current is flowing from high to low, right? And it has some resistivity. Every material has some resistivity, right? Like we can say that if we have the aluminum wire, that's current, it has a different resistivity. Okay. Now let we have the glass rod. Glass rod is an insulator. There's no current flowing in it. Insulator. Current is flowing in a conductors. Okay. So there is no indications. There is no readings. Okay. Now the next thing, if we have the rubber, then what happened? Then also we find there is no deflection. It means no current because it is an insulator. Right. So by this we find that the resistivity, every material has a different resistivity. Like we can say that if we have the aluminum wire, for example, then the resistivity of this is fixed. Resistivity of the aluminum wire is fixed. If we increase the length of the aluminum wire, there is no effect on the resistivity. If the length increase, then effect on resistance, but effect on resistivity is not. Okay, my dear. So here we conclude that resistivity is a specific property of a material. A specific property of a material, and different materials have the different resistivity. Okay, different materials like the copper have different, the aluminum, copper, etc. have different resistivity. Okay, my dear. Resistivity is not depends on the length and the cross section area. If we have the copper wire, if we increase the length, then there is no effect on the resistivity. Okay. Okay. Now let me go on some numericals, right? The first question, on what factors the resistance of the conductor depends. So as we know that depends on what? Length, cross section area, that is material, that is temperature. On both four factors the resistance depends. The second question is, how does the resistance of the wire changes when its length is tripled? If the length is tripled, then the resistance is tripled. Okay, my dear. Length is tripled, then the resistance is tripled. Okay. So we can say that resistance is tripled. Now second one is, its diameter is tripled. If its diameter is tripled, as we know that the area, the cross section area is pi r square. The cross section area is pi r square, and r is the radius. R is the radius, and we can write it, the diameter, the complete diameter is the 2r, double of radius. So r is d by 2, and if you place the r is d by 2, then you find that d square by 4, right? So my dear, by this we can say that if the diameter is tripled, we find the resistance is 1 by 9 times. Is it clear? Right, complete? Okay, so now it's triple then 1 by 9. Okay, so here third one is what? Third one is, if the material is changed to one whose resistivity is 3 times. Resistivity is 3 times. Tell me, resistance depends on resistivity, right? R is proportional to rho. If it is 3 times multiplied, then what? Then resistivity is tripled, resistance is also tripled. Okay, both are proportional to each other. We know the relation. Okay, my dear. Now we are going on the last question. The last question is what? Last question is, will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Right? When the current is flowing more easily, in a thick or thin. So as we know that in a thick, current is flowing more easily compared to the thin. Okay, so this is the answer. So you can write it, when connected to the same source, current will flow more easily through the thick wire. Then the thin wire, R is proportional to what? R is proportional to what? That is 1 upon A, right? If the cross section is more, then the resistance is less. Okay, my dear, this is complete. These are the 3 numericals. So God bless you, right? We will meet in the next video. Okay.